I'd like to welcome Nicolas Jimenez. He's not ashamed to say that he dropped out of PhD in Stanford to start Mathpix. And Mathpix he's the CEO of Mathpix right now, founder and CEO. And they work hard on building infrastructure for creating, search, and publishing STEM content. And they're developing a track for AI software and applying AI into publication, which is really, really nice. With the floor, Nicolas Jimenez.
Okay, thank you. You guys can hear me, right? Okay.
Yes.
All right. Well, thanks a lot for inviting me here. I guess I'll give a talk about, a little bit of history behind, how Mathpix came to be and how, we ended up wanting to address, how we came to develop Mathpix Markdown and, what, kind of how I see, scientific tooling. Mathpix kind of basically started as a class project when I was at Stanford. There's a famous course, CS229, where there's a class. It's a machine learning course. And the course had a class project, and yeah, I always noticed that it was very painful to type LaTeX, right? Very time consuming. And with all the developments of AI at that time, I thought, this might be a problem that you can solve, right? You can just take pictures of your notebook and have it automatically be digitized to LaTeX. You could save a lot of time. So that was the original how Mathpix kind of started, and it turned out it was very difficult. It was a very difficult problem, and at the time the technology wasn't really totally mature yet, but I was still able to make some progress. But then fast forward a year, and I ended up dropping out, just honestly because because I wanted to write software than because I wanted to do Mathpix actually. But so I worked on some computer vision software for about 6 months, and on the side I was working on Mathpix, and I was able to use some of the more recent neural network technologies that had been developed, and started finally getting some interesting results, right? So the side project, it seemed like this would actually be useful, but it was only useful really for simple math. So take a picture of like an integral or algebraic equation, and we could recognize it. And what was our differentiator initially is that we supported handwriting, and so we launched an app, a solver app for kids to help kids do homework, and that got a lot of attention, and we started getting other companies wanting to use our image processing services. So that's when we started building our API, and today we support a lot of the top apps on the App Store for their homework help. But I never forgot the original vision for Mathpix, which was helping PhD students, grad students, and researchers help them actually create math and publish it. And so as we kept improving the technology, we started to see, okay, we can actually go beyond. We can go beyond just algebra, calculus. We can do like real, like hardcore math. And so we we made a big effort to do that, and that was Snip. And so that's the product that researchers, that's our product for researchers. And if you haven't seen it yet, I guess we'll take a look at it in a second. But So maybe I'll show it. I'll show it. I guess let me share my screen. So all right. So we got a bunch of apps going on here. So the basic thing that people wanted to do was that they wanted a desktop app that that could basically copy math to the clipboard. So let's say I see an equation like this, and I want to put it in my document. So boom, it gives me all the LaTeX, copies it to my clipboard, and then I can just paste it. And so that was the first product, and you know, you can if this kind of functionality is useful to you, you know, you can download it from our website. It also works with handwriting very well, but even this tool, even this this snipping, initially it was called Mathpix snipping tool. Today it's called just Mathpix snip. It was really oriented towards just one equation, right? So, you know, input is an image, a screenshot. The output is LaTeX, math mode LaTeX. But and we would render that equation with MathJax. But, you know, naturally people started taking pictures of bigger and bigger pieces of content and wanting other features, like even table recognition. And so basically we had to go beyond just LaTeX, math mode LaTeX rendered with MathJax. We needed a textual representation for the image input that could support mixed text and math. For example, inline math, right? Like here's an example. Oh, maybe not. Actually, this didn't get recognized. Maybe this one. Oh yeah, this is a bug. Never mind. But let me see if I can find an inline math example. Okay, maybe not. I don't have any right here. So we basically had this decision to make, which is how are we going to represent, since what we're doing is we're predicting markup for an image, we had to figure out what is that representation. And since LaTeX is a PDF based tool, that didn't you know that didn't really work for us, because we don't want to wait to render a PDF to show the user result, right? So we want to have a big blob of text that can represent mixed text, mixed math, even tables, and is ideally LaTeX compatible, but we wanted our own engine to render that in our apps using HTML and do that instantly. So that's how Mathpix Markdown came to be. And the first thing that we basically did was very simple and basically fully LaTeX compatible, which is just, you know, recognize, you know, basically say, okay, we're going to support just regular text with math delimiters, right? And we'll just call that Mathpix Markdown, and we'll have a library to render it. And so that's how it started. But, you know, people wanted to support things like tables. Let's see, for example, right here. So this tabular syntax, if you want to render that in HTML, a lot of our users were using us with Overleaf, with a lot of these existing LaTeX tools, and we wanted to give them syntax that was compatible. So, and we wanted to do that for tables. So we actually had to add, to basically build our own rendering engine, which could basically render things like this and give you things on the right side. So that's kind of how Mathpix Markdown came to be, the reason why it existed, that reason why we started building this internal library, this rendering library. And we started seeing people actually use it, right? So there was a real need for it, for us internally to just show the result to the user. And so people started using it that way. And then people wanted, as we began to be able to be, as we developed the capability to process bigger and bigger pieces of content, people asked us, you know, can you process a full PDF, right? So then that was a whole other can of worms, is how are we going to represent the PDF and render it instantly without basically we wanted to maintain compatibility, as much compatibility with LaTeX, but we wanted HTML rendering. So basically what we ended up doing is that we ended up expanding Mathpix Markdown from just, equations and tables to something a little bit more complete that would work for the kind of documents that people wanted us to digitize. And a very common use case was convert this PDF back to the original source LaTeX. So we can see an example of that. So this was a PDF that was processed by our engine, and this is the rendered accessible result. And you can copy, LaTeX, MathML, whatever, to your clipboard. So basically, this is the result of going from PDF to Mathpix Markdown to HTML, and we can look at the original LaTeX as follows. So let's just see what the actual text is here. So you can see we have a title tag, we have author tag. I guess you wouldn't call them tags, maybe elements, section elements, and so we had this problem of how can we represent a PDF in the most compact representation that's still compatible with LaTeX. So we basically what we ended up doing was we basically just took Markdown, which doesn't have that much, and which often supports a lot of Markdown engines, even GitHub. They already support LaTeX, and we said, okay, so let's just take it to the natural conclusion, and let's support all the critical LaTeX that we need to be able to support really good PDF to HTML conversion, if that makes sense. So, and what's nice about this syntax is that it's very interoperable. So that was another issue. Okay, so there's not exactly, there really isn't a big standard of Mathpix or LaTeX flavored Markdown of like existing, and it's pretty hard to build a standard as a company, as a for-profit company, because a lot of standards tend to be built around open source tools. So instead of really trying to build necessarily a standard, we kind of opted for basically backward compatibility with tools that people are already using. So people are already using LaTeX, people are already using Markdown, and so we just wanted to give people as much, and people are already using docx, right? I mean, if you talk to I talked to a chemist a few months ago, and he told me, when his students try to give him papers in LaTeX, he says, I don't want it. He doesn't want to deal with it. He wants to use Word. And this is, so people are still using Word as well. And so that was another thing that another benefit of this kind of restricted LaTeX Markdown thing is that it can, not only can you generate HTML really well, but you can also export to all these different file types. So let's take a look. So I'm going to export this to docx. It's a fairly big file, but so that's another common use case that we have is users wanting to use us to do PDF to docx. So you can see we got all the tables, you got all the equations, and it's even editable. So that shows our PDF to docx conversion. And then let's see. Let's try some of the other guys. So we also have a PDF with LaTeX renderer that we'll show right here. So there you go. This was rendered with LaTeX. And it's not, and it's not that, you can imagine how converting this Mathpix Markdown to LaTeX is going to be a lot easier than converting generic LaTeX, right? And so that's kind of an interesting thing, which is that basically the way I see it, LaTeX was built as, you know, this really powerful tool for generating PDFs, and so there's really nothing quite like it. So I don't really see that necessarily anyone really needs to replace LaTeX. I think for what it does, there's really nothing like it. And but can we help? Can we still add value? You know, make it easy for people to either edit existing PDF files for which they don't have the source, or even just work with existing PDFs. For example, we have a feature that lets you search for math terms inside PDFs, right? So we actually, not only do we convert PDFs, but we also allow users to build a searchable PDF cloud where they can actually search for math terms and equations, which is pretty cool. And people can switch to HTML mode from any point in their document if they want to copy an equation. Let's say I want to copy this equation, and let's say I want to add it. I want to paste it, boom, right there. So we've built this kind of rich, interoperable tooling where we don't want to lock people in. It's the opposite. We want to let people use whatever they're already using. If people want to use DocX, that's fine. Our tool is DocX compatible. If they want to use LaTeX or PDFs, that's fine. And I guess one thing that's interesting about PDFs is that there's this question of why are we still using PDFs in scientific tooling? And I think an important reason is because it's basically the format for multiple images, right? And if you want to, what other file type can you send multiple images in? Really, there's not really a multiple image format. PDF would be what you would use. So I think for archival reasons, PDFs are still the way to go, because all this legacy data is already in PDFs, and so good luck replacing that. And people are still used to their LaTeX based tooling. But what we wanted to do is build something where you can still export to LaTeX. You can get your LaTeX document, but you can write your document in a slightly easier way, right? That's HTML first. So our approach to STEM documents has been HTML first and LaTeX PDF second. So I can even export to Overleaf. I can export to LaTeX zip file. I can still do that, but I get all the benefits of writing Markdown and fast rendering and being web first, being able to share web links that have documents, and get things like accessibility, which is something that an increasing number of our customers, or an increasing number of customers, have been using us for. I'm not sure you're going to be able to hear this. Did you hear that? Maybe not. In any case, you guys probably can't hear that, but basically it's reading out the math. So we have an option that makes math that makes the documents we create really compatible with screen readers. And this is possible both within the editing within our editor as well as within our PDF engine. So what's a typical use case for our editor? So let's say I have right in front of me, I have an equation written on a piece of paper, and I'm going to take a picture of it with my phone. Okay. So I can go here, find the equation, insert it, and there you go. Right. So this is what I took a picture of in my notebook, and I have it. It's accessible. It's, you know, I can export it to LaTeX, docx, whatever. And so that's the core. That's still the core use case for us. Is still most people are using us as basically a document conversion tool to go from images to LaTeX, PDF to LaTeX, PDF to Word. So that's still what people are using us for the most part, and we save people a lot of time. So I can look maybe we'll take a quick look at some of the critical features that we borrowed from LaTeX. So basically the idea is we wanted to make as few changes to Markdown as possible while still being usable for scientific documents. Because that's really the issue with Markdown is great for HTML, but there's certain nice things that you have in LaTeX, like equation referencing, sections, authors, title sections, things like that you really want in a tool that's specifically for researchers. So that's what our approach was, is just add the minimal amount of features to Markdown, make them completely compatible with LaTeX. So you can copy paste between LaTeX and Mathpix Markdown. And yeah, so we have equations that linkable equations. That's a really nice feature of LaTeX. And so we have all these nice features of LaTeX as well. And without those, it's kind of a pain creating. You don't really have Markdown doesn't have quite the expressiveness. Another short down of Markdown is tables. So Markdown tables, if you guys have had experience with that, I mean, it works, but it's not doing things like multiple column cells or cells that have multiple rows is really painful. So, and we have this documentation, and we actually use, this is actually rendered on the web page using Mathpix Markdown. So I can take this piece of tabular syntax, and I can just paste it in. And so this tool is open source. We do have it on GitHub, Mathpix Markdown. So let's see. Yeah, so we do have it on GitHub, and it's compatible with our OCR. So because, I mean, that's basically what was that was the impetus for even developing it, is because we do emit visual content to markup, but to show the user, we definitely need markup to HTML to make something renderable. So let me see. That I guess that's pretty much the main things I wanted to talk about. So that maybe wasn't the full time. Definitely, that went pretty fast. But maybe you guys have questions. Can we do that part?
Yes, of course. I mean, we can open up the floor for questions. I already have a few of my own.
Okay.
I don't know if you know about previous research on OCR in mathematics. Do you know about the software made by the Japanese and the research made by Richard Feynman in Berkeley? And Richard Feynman, I in fact worked on with the group that made that particular one. He wrote in the late 80s an OCR that was literally reading, a huge book of integrals, and he did a beautiful piece of work, which is OCR, an entire book, and then checked the integrals on maxima, which was the symbolic manipulator of the times, and numerous errors were found on the tables of integrals, just using his OCR. And I remember that he had a way to sort of eat a formula, which he would look for a divider, like a huge fraction sign, and then start reading the top, and then start reading the bottom, and composing the functions and so forth. But my question to you is, does Mathpix have a product that will just scan an entire book by itself, or do you always have to build a contract and go on using the API to do that?
So you can upload a whole PDF and we'll process it for you. So
and hand it back to us.
Yeah. So let's see if I drag this one in right here. So yeah, people have used us with books, but books have certain elements that we don't yet support that well. So I would say our tool works better with tools with research papers than with books, but it still works with we have had people use us with books, especially specific chapters of books.
Uh-huh. Do you have a question for the engineer?
So Dion is asking, yes, we are using MathJax. Is the official list of supported MathJax macros the full range of what Mathpix covers? Are those macros sufficient for all of STEM content mathematics? So I think there are some gaps in what we currently offer. For example, people have asked for some of the proofs packages, but basically we support everything that, for the most part, everything that MathJax also supports. I see another question about the index command seems to get swallowed up. Index. I'm not even sure what the index command does, to be honest. I don't totally remember.
This is from LaTeX for a paper or a book where you're creating an index, and so you have markup \index giving an entry that goes into the index or an entry in a sub-entry. And I just tried that in PDF. When the PDF is converted to HTML, that the content of that index command just appears as is right in the body of the text. So it's not rendering that.
I'd love to see what that looks like. Maybe you could share your screen, I guess, or
Sure.
Is there a way to? Yeah. Okay. Let me stop sharing.
Let's see. Where do I? There we go.
Index. And what does that look like when you render it?
So when you render it, Nico, you will just produce an entry on the index of the book.
So index, you mean table of content? Is that what you mean?
Not exactly the table of content, but the other index of the book, which is the index where you define, you put the definition of the terms. So on the text, you get nothing, but you get an entry on the index on the back of the book. You know, the table of contents in general is on the front of the book.
Right, right. So no, that's not something we currently support, but I mean that would definitely be something that we could think about supporting, but yeah, we don't support that yet. So in terms of in terms of I mean, it kind of depends on what the use case is, right? So there's people can use us for multiple things. One of them is just getting, if you don't have the source, just getting something editable, being able to edit a PDF. And people can also use us for creating basically a research collection of PDFs. And so this is something that, you know, we're really excited about, because it's really nice to be able to search all your PDFs and be able to to click on a button and, you know, you just go right there. It brings you right to the point of the PDF. So that, and being able to copy text from the PDF and put that in your in your document. Those are kind of the major use cases for PDFs. We don't really anticipate ever having totally perfect OCR. A book, but we can save people a lot of time, right? So if the goal is to go, you know, from a PDF, from a full book to a perfect, you know, markup, that's going to take some manual work for sure. And so that's something that we're not really doing now, but that's something maybe one day we would do, where we would offer a service where we don't just OCR it, but we also do some of the human corrections. But that's not as much of a problem for, you know, single equations. So we've gotten really good at handwriting recognition recently. So even that just by itself is really nice, because you can basically create a full document of equations. You can put in all your equations here and either export it. Hello, you can't hear me? Oh.
Yeah, we can hear you.
Okay. Someone said maybe they can't hear. So you can create a document with all your main equations and either export it to PDF right from our tool, or you can export it to Overleaf or DocX, finish it wherever. But you can create that if you're doing a lot of mathematical work, we save people a ton of time with digitizing their handwritten equations. So that's kind of the stuff that we're really good at right now. We're really good at saving people time with, you know, just going from their notebook to their notes and making PDF searchable. And so those are right now the you know, where we excel, and we've developed Mathpix Markdown to support all of that tooling.
Nico, I have a follow-up question. How much of that is just OCR technique or versus AI in order to do the job of the translation?
So we don't use old school OCR techniques. We started with that.
I don't know if you can say all that it is, but they're just interested in it.
Sure. So we started using a normal, you know, more traditional OCR techniques in the beginning when this was just a class project. That's basically how it was built. But, you know, it never worked. It never worked very well. So our approach today is very data driven. We have a huge number of equations, you know, from all written in all types of fonts, different books. Old books, you know, have funky weird fonts. New books, as well as handwriting from different parts of the world. People in China write equations different than people in Eastern Europe, and they write equations different than people in America. So we write different equations differently than people in India. So we have global kind of data set of equations, and so that's basically how our OCR is powered. It's very data driven. We train, and it uses it uses like really cutting edge deep learning technology, and some of which is relatively generic, and some of which is actually pretty novel, especially when it comes to parsing pages. So that was kind of a very difficult thing for us, a very difficult problem, and we've basically solved it, which is, you have a page, let's say of a page of printed or handwritten content. How do you parse that into different blocks? How can you do that in a good way, right? With good error. Basically, a lot of the work that we've done on machine learning and AI side has been preventing bad outcomes. So that's like a really important part of AI, right? So AI is really easy to get that 90%, accuracy. But what happens when the algorithm is challenged? What are the error modes, right? When it fails, how does it fail? And are the failures somewhat reasonable? Or are they like really, are they schizophrenic and end up generating invalid syntax? So those are the kind of things that where we've innovated, is building an algorithm where people don't get that bad experience, right? I think a lot of developing software is sometimes more about preventing negative experiences rather than even enabling great ones, right? So someone asked, what about TIGSI support? So that's a great question, and we do want to support TIGSI. We want to support something that would be at least compatible with TIGSI, such that maybe we have a syntax, we have some Markdown extension for diagrams that if you export it to LaTeX, it could export to TIGSI. So we do want to do something like that, but we may do it slightly differently. We may support TIGSI and other diagrams slightly differently than how we do math. So right now we don't have immediate plans to do diagrams, but that is something that people have asked us, and we do want to. One thing we want to do, for example, is commutative diagrams. So those are what's tricky is the tough thing is that people want us to do the hard stuff, right? So the harder it is, the more valuable it is to the user. But then for us, it's like, wow, this is really hard. Like commutative diagrams. I mean, and tables was actually really tricky too, because we had to not only innovate on the OCR side, but we had to innovate on the rendering side, because, okay, you have some tabular syntax. How do you even show that? How can you make sure it's valid? How can you show it to the user? So we've had to innovate on some of these rendering topics as well, including for like chemistry is another example of something that we support in with Mathpix, but we had to build a bunch of rendering technology, which makes sense, right? So because what we're doing is image to markup, and you want to be able to get back to something that looks like the original thing that the person wrote. So, but we will add diagram support, and what I actually want to do is I want to have like an iPad type of interface for digital, like a more digital ink interface for diagrams, because I think if it's more interactive, it's going to be a little bit easier to do that really accurately, right? So like if you want to draw a binary tree, or you want to draw maybe even a commutative diagram, or what are some other, just a flow chart. But for computer scientists, it would be really nice to have this interface. So that's something that we want to do. But actually, I'm biased towards wanting to do it on the with using digital ink. Whereas for most of our math stuff, so we're very visual. So we've been very visual because equations are relatively readable. There's not there's good syntax for it. They're regular. That's an important thing, is that they're pretty regular. They follow a certain grammar, a certain visual grammar. So once you start talking about diagrams, the diagrams are so unconstrained. Like, they can be anything. Any group of arrows going any which way, that's still a diagram. You can't, right? Whereas equations, are highly constrained. Like, it's going to be subscript, superscript, fraction, square root. There's only so many elements, and they're arranged in regular formations. Whereas so diagrams is a really challenging problem, and that's kind of why I think I want to do it with an interactive digital ink interface. But anyway, that's just for the future.
Cool. Well, thanks very, very much, Nico. Nice talk, and nice to see people working on applications of AI and the creation of markup.
Awesome. Yeah, I'm glad I got to talk to you guys. So if you guys have any follow-up questions or things that don't work, you guys can just email me. Here's my email. I appreciate the chance to present to you guys, and yeah, good luck with the rest of the symposium.
Thank you very much.
All right, thank you. Bye.